So this is another question from May-June 2021 paper. Dinitrogen tetroxide, which is N2O4, which decompose into nitrogen dioxide, the reaction is reversible. Means the reactant can form a product and a product can decompose and form back the reactant. So a gas syringe containing a mixture of dinitrogen tetroxide and nitrogen dioxide. After reaching equilibrium, the mixture was pale brown in color, means light brown in color. Then what is meant by the term equilibrium? So as we did in yesterday exam paper, whenever the question is related to define the term equilibrium or explain the term equilibrium, the first thing you will mention that the rate or the speed of the forward reaction is equal to the rate or the speed of backward reaction. That is 1 mark. The second point, there is no, whenever the reversible reaction is in equilibrium or whenever a reaction is in equilibrium, there is no change in the concentration of reactant or product. But don't say the amount of reactant equal to the amount of product. It's not like if I say I will have say 2 dm cube of this and the 2 or say 3 grams of this and 3 grams of this. That does not mean equilibrium. Equilibrium means that their amounts might be different, but the speed at which the forward reaction occur will be same as speed at which the backward reaction occur. So there will the forward reaction equal to backward reaction, and there is no change in the concentration of reactant or product. Yeah, that's right. So there is no change in the concentration. In part B, the plunger. In part B, the plunger of a gas syringe is pushed in. The temperature does not change. Look, you have reactant and product. Whenever, what is the effect of pressure? Increase in pressure, shift the equilibrium towards the side where number of moles are less. So if you increase the pressure, where the equilibrium or the balance will shift, it will shift towards left-hand side. So as it shifts towards the left-hand side, what should happen to the color? Because we should have more colorless gas. But what happened? See, if you have two substances, one is N2O4, which is colorless, does not have any color. And another one, you have NO2. Reactant side, you have 1 mole, and the product side, you have 2 moles. So increase in pressure, shift the equilibrium towards side where number of moles are less. So you have N2O4, 1 molecule, and you have NO2, 2 molecules. So when we increase the pressure, because when you increase the pressure, you reduce the volume, means the particles come closer to each other. So when the particles, initially when you compress, the particles will come closer to each other. As a result, when the particles will come closer to each other, the color will get initially darker. Why initially the color is getting darker? Because when we are compressing, the particles are coming closer. But then what happened after some time, the color get lighter. Why the color get lighter? Because now the NO2 start to decompose and form N2O4. So explain why initially it turned dark brown. What is the reason why it appeared to be dark brown? Because the particles come closer to each other. So when the particle come closer to each other, the color appeared to be darker. And then why the position of equilibrium shifted to the left-hand side? Because there are few moles of a gas. There are few moles of the gas on the left-hand side, and remember, increase in pressure shift the equilibrium towards the side where number of moles are less. So here you have 1 mole of molecule, and here we have 2 moles. So when I increase pressure, it will always shift towards side where number of moles are less. So they mentioned the forward reaction is endothermic. So if the reaction is endothermic, it means the reactants will have, when we draw the energy profile diagram for endothermic reactions, reactants will have low energy and the product will have high energy for endothermic reaction. As I mentioned, the forward reaction is endothermic. So N2O4 and NO2. So what happened? What happened to the position of equilibrium when the temperature increased? So increase in temperature where the equilibrium shift, because we have both reactant and product, but reactant energy is less. So most of the energy will be absorbed by the reactant and they will start to form product. So for endothermic reaction, increase in temperature shift the equilibrium towards the right hand side. And state what happened to the rate of forward and rate of a reaction. Even it's a reversible or irreversible reaction, rate depends on temperature. If you increase the temperature, rate will also increase. If you decrease the temperature, rate will decrease. So in the question, we are increasing a temperature. So even it's a forward or a backward, reversible or irreversible reaction, rate will always increase. So rate of the reaction has nothing to do with the type of a reaction. Even it's a reversible or irreversible, rate always increases with temperature. But if it's a reversible, then the equilibrium might shift either left or the right hand side, depending on what we carry out or how we carry out or what kind of reaction. In question 5, this question is about salt. We are preparing insoluble salt. So when we are preparing insoluble salt, the reaction is known as ionic precipitation. So what we do, we mix two salt solutions. As a result, it will form a solid and another salt solution. This solid is known as PPT. So this is how ionic precipitation is done, by mixing two solutions, two soluble salt solution. So lead 2 iodide is insoluble. So all nitrates are soluble and all sodium salts are soluble. So I want to prepare lead 2 nitrate. Or I can say I want to prepare lead iodide. So which two salts I should mix? So first thing, we have to identify which salt we should mix. You are provided with lead nitrate. So we have already in the question, we have a lead nitrate and we have sodium iodide. So lead nitrate and sodium nitrate, lead nitrate and sodium iodide are there. As a result, when they mix with each other, what they will form? It will form lead iodide plus sodium nitrate. This is called ionic precipitation. This will be aqueous. This is aqueous, this is aqueous, this one is solid, and this one is aqueous. So in the question, describe how would you make a pure sample of a lead 2 iodide? Your answer should include practical details and a chemical equation for precipitation. So first, what we do, we have a solid, we have a solid lead nitrate and we have a solid lead iodide. First thing, what we should do, we'll take two different test tubes. And in one test tube, we will add lead 2 nitrate. And the other test tube, we will add sodium iodide. Then we have to make a solution. So we'll add water to make the salt solution, add water and stir. So we'll have a salt solutions. And we mix these solutions together into another test tube or into another container, or we can transfer solution from one test tube to another. So as a result, what we'll observe a precipitate or a solid is formed. So how to obtain this solid? This solid is actually, this was lead nitrate, and here it is sodium iodide. When we mix them together, the result is lead iodide, and a solution of sodium nitrate is there. So how to obtain this lead iodide? So we'll filter it, then we will wash. If it is an insoluble solid, we can wash it. But if it is a soluble solid, we don't wash, otherwise it will dissolve. So we will filter, then we will wash to remove any trace of impurity. And after that, we can dry. Yeah, we can dry with the tissue paper or filter paper. Then we have to write the equation for this. So what will be the steps? As I mentioned, we'll add water to each salt, make a solution, then we'll mix them together. It will form a precipitate. We will filter and then wash and dry the residue. Then what is the chemical equation for precipitation or ionic equation? Here, lead nitrate is reacting with sodium iodide. So we can write the direct ionic equation, that lead ion we can write both ways. We can write the full symbolic equation as lead nitrate. Formula for lead nitrate is PbNO3 bracket 2. Lead 2 nitrate is there. Sodium is group 1 and iodine is group 7. So sodium iodide is NaI. And as a result, when they combine with each other, it will form lead iodide. So it will be PbI2 plus sodium nitrate or NaNO3. Then equation must be balanced. So if I put 2 here and I put 2, so this equation is balanced. So this one is aqueous, solid, and aqueous. So you have to write in your own words that how you carry out this and prepare insoluble salt by mixing the two salt solutions. Then nitrates decompose when heated. When hydrated zinc nitrate is heated, oxygen gas is given off. Describe a test for oxygen. So if you want to test oxygen, we can use a glowing splint. And we can say observation, it will relight or rekindle. Then complete the equation for a decomposition of hydrated zinc nitrate. Use the screen annotation to balance this equation. Balance the equation, use the screen annotation. Yeah, that's right, 2. This one is 4. And how many hydrogen should be there? Because this is 6 multiplied by 2, 12. So we should have a 12 hydrogen. And this is 12, and that 2 is also multiplied. Hydrogen, not the total number of hydrogen. See, how to identify the total number of hydrogens? This 2 is with both of them. So already it is 6 multiplied by 2 is 12. And this 12 is multiplied with 2. This 2 is with both zinc, nitrate, and water. So 12 multiplied by 2, 24. So basically we need 24 hydrogen. That's why we put 12 into 2, which will make 24. Some sulfates are hydrated. Hydrated means that they contain water of crystallization. When hydrated sodium sulfate is there, normally when we supply heat energy, so this water of crystallization is given off. Like if we have a hydrated sodium sulfate Na2SO4 dot XH2O, when we supply the heat energy, it will become Na2SO4 plus XH2O, like X water molecules are being released. A student carry out an experiment to determine the value of X. So student want to determine the value of X. So basically how we can work out, we'll find the moles of sodium sulfate and we'll find the moles of water, and then we'll take a ratio between moles of sulfate and sodium sulfate and water. Like if the ratio is 1:2, it means X is 2. If the ratio is 1:3, so X is 3. So what student did, step 1, hydrated sodium sulfate crystals are weighed. So student put hydrated sodium sulfate crystals in a crucible. Then hydrated sodium sulfates are heated. Why these hydrated sodium sulfate crystals are heated? So that it can lose water of crystallization. That water can be removed from this hydrated crystal. And the remaining solid is reweighed again. How the student can check that all of the water has given off, like there is no more water left. So student can repeat this experiment until the mass remain constant, until the mass does not change. For example, say student started with a mass of a 2 gram. The initial mass of a solid was 2 gram. Student supply heat energy and then he weighed again, he got 1.8. Then he supply energy again and he reweighed, example, he got 1.6. Then he supply energy and reweighed again, it is also 1.6. So once the mass is not changing, then we will know that there is no more water of crystallization left. All of the water has removed. So heat until the constant mass. Or heat until the mass does not change. So we'll make sure that the water of crystallization is completely lost. And we can one mark mentioning heat until the mass is constant, and the second is reweigh again or repeat the process, step 2 and 3. In an experiment, 1.61 grams of hydrated sodium sulfate is heated. The mass of a sodium sulfate left is 0.71. So if we were having, like example, Na2SO4.XH2O, the total mass of this compound was 1.61. And when we supply heat energy, the mass, because water will be escape as a vapor, so this one is 0.71 grams. So how much water vapor or how many, what mass of a water is being removed? So how to work out the total mass, which is 1.61 minus 0.71. So it will be 0.9. So 0.9 grams of water will be there, because the total mass before and after should be same. If 0.71 is sodium sulfate and remaining water mass will be there. Determine the value of X using the following steps. Calculate the number of moles of sodium sulfate remaining. So what is the mass of a remaining sodium sulfate? 0.71. And they give you the molar mass of sodium sulfate is 142, and for water it is 18. So we'll use a formula, moles equal mass in gram divided by molar mass. So moles equal mass in gram for sodium sulfate 0.71 divided by molar mass is 142. So 0.71 divided by 142. This is 0.005. So 0.005 moles of sodium sulfate. Then calculate the mass of mass of water given off. So how to know the mass of water? If the total mass of a compound was 1.61 and sodium sulfate is 0.71, so we will subtract to know the mass of water or H2O given off, which will be equal to 0.9. So this was 0.005. This is 0.9. Then number of moles of water. How to get the moles of water? Again, we'll use the formula moles equal mass in gram. which is 0.9 divided by molar mass of water, which is 18. So 0.9 divided by 18. So 0.9 divided by 18 will give us 0.05. So the moles of the water are 0.05. Then what is the value of X? So we'll simply take a ratio between sodium sulfate and water in their moles. Sodium sulfate moles were 0.005 and the water moles are 0.05. Whenever we have want a simplest ratio, we always divide by the smallest value to get the simplest ratio. So the smallest value is 0.005. So we'll divide both of them by 0.005. So this will be 1 and the other one, it will be 10. So it means if we have 1 molecule of sodium sulfate, we will have 10 molecules of water. So the ratio between sodium sulfate and water is 1:10, or the value of the X is equals to, because it was Na2SO4.XH2O, means how many sodium sulfate combined with water. So the ratio, when we work out the ratio, it is 1:10. So what should be the value of the X? So the value of X should be 10. Is it clear? Question 6 is about extraction of the iron. Look, the last part I will repeat. In the last part, how we get the value of X? We calculated the moles of sodium sulfate because it is written Na2SO4.XH2O, like Na2SO4 combined with X water molecule. So how many moles of Na2SO4 are there? 0.005. And how many moles of water are there? 0.05. So when we take a simplest ratio between them, their moles, the simplest ratio between them, we divide by the smallest value. So smallest value is 0.005. So when we divide, for sodium sulfate, we'll get 1, and for water moles, we'll get 10. So it means 1 mole of sodium sulfate will combine with 10 moles of water. So if the value of a sodium sulfate is 1, what should be the value of the water? It should be 10. That's why the value of X is equals to 10. We always take the simplest ratio between the moles to get how many water of crystallization or molecules of water are attached to a compound. Discussion is about the extraction of iron, which is the main ore is hematite. So we use a raw material, coke, iron ore, limestone, A, B, and a molten iron is removed. Name the ore of iron used in the blast furnace. So what is the ore or name given to the ore of iron? So that is hematite. The ore of iron, ore of zinc is zinc blende, aluminum is bauxite, and iron is hematite, Hematite. Then name the substance that enter the blast furnace at A. So what we do, we blow a hot air from the bottom so that the oxygen which is present in a hot air can react with a coke or a carbon to give off carbon dioxide so that the furnace temperature increases. So from the bottom, what should be added? The hot air. Name a substance that leaves the furnace at B. So yeah, that's right. What is removed from the furnace at B? Because molten iron is at the top, and what we have above that we have a slag. The slag which is formed by reaction of calcium oxide and silicon oxide. Give 2 reasons of using a coke in the blast furnace. So what is the purpose of using a coke? This same question they can ask in the extraction of a zinc as well. So coke, first thing, it is used to produce the heat energy or increase the temperature of the furnace, or as a source of heat energy or release heat energy. And second thing, it can be used as a reducing agent, or it can produce carbon monoxide, which is a reducing agent. So first thing, it is used to produce heat or a source of heat. That is one thing. And the second thing, use as a reducing agent or produce a reducing agent such as carbon monoxide. Carbon monoxide is formed in extraction of iron. Basically what happened, carbon react with oxygen, give carbon dioxide. And then the carbon dioxide further react with more coke to produce carbon monoxide. So I can mention reducing agent, or I can mention here that used to produce carbon monoxide, which is a reducing agent. Both ways it is correct, because carbon or carbon monoxide both have the tendency to remove oxygen from a substance or can be used as a reducing agent. Another ore of iron is iron pyrite, which is FeS2. Iron pyrite contain a positive ion iron. Deduce a formula of a negative ion. So look, we have FeS2. So if iron is having a valency, because what is the number written here is the valency of iron, and what is the number written here is the valency of sulfur, according to, or valency of the other element. So according to this formula, if it is FeS2, so what should be the valency of the sulfur? It will be -1, because this is how we identify the valency of a compound. Or if I say, like example, I have sodium oxide. So what is the valency of sodium and oxygen? So what number is written with sodium is the valency of oxygen. And what number is written with oxygen is the valency of sodium. So it will be -2, and the first one will be +1. Same thing if we have iron sulfide. So what is the valency of iron? That is +2. And what is the valency of sulfur? What number 1 is there? So it should be -1. Because the first element will have a positive valency and the second element will have a negative valency. Then iron is a transition element. A list of properties of iron shown. Give 2 properties from a list in which iron differ from group 1. So can you take the properties which iron differ from group 1? Use a screen annotation to take which properties are present with iron but not in group 1. So variable oxidation, 2 properties we have to take. Variable oxidation is 1. What else? So form colored compound, that's right. So then give 2 properties in the list. Yeah, can act as a catalyst, that's right. So these 3 properties are actually the similar different properties compared to group 1. Then give 2 properties from the list which are similar to that of group 1. Like group 1 and these, they have the similar properties. So good conductor of electricity and form a basic oxide, that's true, because metal oxides are basic, or it can be amphoteric, but group 1 also produce basic oxides. Then this is how we protect. This is how we protect the iron from rusting. This is a sacrificial protection. Magnesium is more reactive than iron. So magnesium, explain how magnesium block prevent the iron from rusting. So what are the steps? Magnesium is more reactive than iron. Magnesium oxidizes or loses electron. So iron is not able to lose electron, or iron is not oxidized, because for oxidation to occur, iron must oxidized. So here you will mention magnesium. 1 mark, magnesium is more reactive than iron. The second mark, magnesium loses electron and oxidized, and it prevent the iron from being oxidized, because when iron oxidizes, it will rust. If iron does not oxidize or lose electron, it does not rust. Explain why replacing a magnesium block with a copper will not prevent the board from rusting, because copper is less reactive than iron. So in that case, the iron will oxidize instead of copper. Then we have to work out the empirical formula. Many organic compounds contain carbon, hydrogen, oxygen only. The organic compound B is having 48% carbon. So we have to find empirical formula. What are the steps for finding empirical formula? So 48.65, 8.11, and 43.24. The first step, divide by atomic mass. So using a periodic table, you will divide this by 12, you'll divide this by 1, and this by 16. So we'll divide the percentage of a carbon by 12, percentage of hydrogen by 1. That does not make difference, and oxygen will divide by 16. So 48.65 divided by 12, it will be 4.05. This will be same 8.11, and 43.24 divided by 16, 2.7. Then the second step, we divide by the smallest value. So the smallest value here is 2.7. So we'll divide all of them by 2.7. So this will be 2.7, 2.7, and 2.7. So when we divide by 2.7, this will give us 1.5. This will be 3, and this is 1. Now, whenever one of the values 1.5, 2.5, 3.5, we multiply all of them by 2. So this will be 3 carbon, 6 hydrogen, and oxygen. So empirical formula is C3H6 and O2. So C3H6 and O2 is the empirical formula. Then compound W has a molecule empirical. So there's another compound. This is compound V. Now there's a compound W. So compound W is having an empirical formula CH4O, and relative molecular mass is 32. What is the molecular formula? So molecular formula is empirical formula times N. Empirical formula is CH4 and O. And what about the N? N is a molecular mass, which is 32, divided by empirical mass. So carbon is 12, hydrogen is 4, and oxygen is 16. Multiply by 4. Hydrogen is 16, not multiply by 4. Hydrogen is 4. So 16 multiplied by 1. This is 1 multiplied by 4. And this, so it will be 12 plus 4, 16, and 16 plus 16, 32. So empirical mass is also 32. So value of N is 1. So when value of N is 1, we'll have the same molecular as well as empirical formula. So it will be CH4O. So empirical formula times N is equals to molecular formula. Then compound X and Y have the same general formula. X and Y are both carboxylic acid. We have to write a general formula. Look, it is written C2H4O2. Then it is C4H8O2. We have to make a general formula, like as when you compare, like if carbon is 2, hydrogen is 4, so it is double. When carbon is 4, hydrogen is 8, it is also double. So if carbon is N, hydrogen will be 2N. And what about oxygen? Oxygen remain 2 for both of them. So it is CnH2nO2. Because oxygen number is not changing. So it remained 2. That's why we put 2. Is it clear?